So how many liters of O2 gas at 25 degrees Celsius and 1 atmospheric pressure are obtained by the thermal decomposition of 0.200 grams of KMnO4? The balanced equation for the reaction is shown right here on the whiteboard. And so we find how many milliliters of O2 gas. So they give us the pressure and the temperature. So from this, since it's a gas, you should be thinking of the ideal gas law. The ideal gas law is PV equals nRT, where P is pressure, V is volume, N is moles, constant, and D is temp. So what you first want to do is calculate. So we have pressure and temperature and the constant. We need to find moles, and we're solving for the volume of gas. So first moles. So they give us 0.200 grams of KMnO4, right? So if you want, so we have grams of KMnO4, but we want to convert it to moles of oxygen. So first you need to convert the grams of KMnO4 into moles of KMnO4. So how do we do that? Well, we know that in 1 mole of KMnO4 there is molar mass, and you go to the periodic table and add each of the weights up, and then which is 39.1, 54.94, and then since there are 4 oxygens, 4 times 16. And then after this calculation, you have moles of KMnO4. But now you want moles of oxygen. So what do we need? We need to find moles of oxygen. So this equation comes in handy. So if you want moles of oxygen, right? So you want oxygen on the top. And if you look at the equation, for 1 mole of oxygen, there are 2 moles of KMnO4. So you always look at the equation for the mole conversions. Depending on the coefficient in front of each compound in an equation, it could change. If you don't look at this, then your answer can change and then you get the wrong answer. So you do this, and now you have moles of oxygen, which equals to be 0.00063 moles of oxygen. Now, you have your moles, you can plug in all your values into the ideal gas to the volume. So that the pressure that they give us is 1 atmosphere. So 1 atmosphere times the volume, which we need to find, equals the moles, 0.0000633 moles times the R value. This is always constant, and you will have to look this up, but it's 0.0821, and then it's like liters, atmospheres over mole kelvins. And then they give us a temperature which is 25 degrees Celsius. And you have to note that in the ideal gas law, the temperature is Kelvin. And to convert any temperature from Celsius to Kelvin, you must add 273. And in this case, that is 298 Kelvin. And after you once you calculate this, you get a volume of 0.0155. Okay, look at it. It says they want it in milliliters, and in this ideal gas equation, you know that the volume is in liters. So now that you have liters, you must convert it to milliliters. So you multiply 0.0155 by 1,000, and then your resulting answer would be 15.5 milliliters.